looked at the sum of an arithmetic sequence. In other words, an arithmetic sequence or series. In this video, we're going to look at something that's being multiplied, right? So 3 times 3 times 3 will give me the next term. That's the definition of a geometric sequence. So we're going to learn how to quickly add the terms of a geometric sequence together. In other words, we're looking at geometric series. One more example, this nth term sequence. Just like before, we're multiplying by 3 to get to the next term, meaning the ratio is 3. So when I'm writing this g sub n stuff down, I write 3 to the n minus 1. That's the ratio. Only thing different is the first term I write 4 instead of a, because that's the first term. Let's find S4. That's the sum of the first 4 terms of this sequence. That would be 4 plus 12 plus 36 plus 108. That's 160. Now, if I asked you what the sum of the first 100 terms is, you would probably lose your mind having to type out, right, times 3, and then finding the first 100 terms and then adding them together. So we want to look at being able to do that quickly and easily. To do that, we'll have to prove how to find this quickly and easily. S4, just a little differently, right? This is like saying the first term, 4, plus the first term times 3, plus the first term times 3 squared, plus the first term times 3 cubed. Right? That's literally what that stuff means. If I were to find S sub n, so the sum for any nth term, that would be like saying, well, let's look at this, right? That would be the first term, right? A plus a to the times r to the first power plus a times r squared plus a times r cubed. And notice that, right, this fourth term, s sub 4, that would be like 4 minus 1 is 3. So that means when we're adding s sub n, and we go all the way down here, it would be a times r to the n minus 1. Replay that part over and over until you see that. Step is to take this s sub n and multiply it by the ratio. So r times the sum is equal to, look at this, a times r plus a times r squared plus a times r cubed, all the way till this last term. And now instead of it being n minus 1, it's a times r sub n. So like what happened in between? Well, I multiplied r times Sn, right? And I multiplied r times a plus ar squared. And what I did here, from here to here, is I distributed the r. Watch that as many times as you need to understand it. This one and this one again. I've written those two again neatly. And the next thing that I'm going to do, I'm going to subtract these. I'm going to go S sub n minus r S sub n. So when we do that, watch what happens. I have S sub n minus r times S sub n. That's equal to a, and look, I'm subtracting all of these. Look at this. I'm going ar minus ar, that's 0. Er squared minus ar squared, that's 0. And all of these are going to cancel out in between until I get to here. Right? Those cancel out. Those are the same. And I'm going to get, right, this minus a r to the n. And once I get here, I've almost finished this really clean, nifty formula. I just need to do GCF on both sides. So do that. From here to here, right, I did GCF. These both have S sub n in common, and what's left is 1 minus r. These both have a in common. What's left? 1 minus r to the n. The last step is I isolate for S sub n by dividing by 1 minus r. And so I get S sub n equals a times 1 minus r to the n all over 1 minus r. Nothing else cancels out. It's just like that. That's the formula. So earlier we were trying to find S sub 100. We're going to find it now. S sub 100, the series of the sum of the first 100 terms is equal to the first term, which for this one was 4 times 1 minus the ratio. The ratio here was 3. And that's to the n power, so our n is 100, all over 1 minus 3. And that equals the sum of the first 100 terms.